Welcome to Maths for E channel. A past question on a trigonometry from Sri Lankan A-level past paper. Write down sine A plus B in terms of sine A cos A, sine B cos B, and obtain a similar expression for sine A minus B. Let's do that first. Simply, sine A plus B equals sine A cos B plus cos A sine B is a trigonometric identity or trigonometric property, one of the trigonometric properties. And then let's obtain. Having said obtain this, and again the second one is a trigonometric property. We can simply write it sine A minus B is a sine A cos B minus cos A sine B, but it's just having used the word obtain, so just they want us to use the first part, equation 1, and find the equation 2. So A is A, only B is minus B. So this, instead of cos B, is cos minus B. That is equal cos B. And here sine B, it's instead of sine B, that is equal sine minus sine B. So if you could substitute these to equation 1, sine A minus B equal sine A, and because of cos B, cos minus B is cos B, so cos A, cos B same. And cos A, sine B is minus sine B. So minus times plus is minus, that's minus. Therefore, sine A minus B, sine A cos B minus cos A sine B. That's first part. Second part, deduce that sine A cos B equals sine A plus B plus sine A minus B. 2 sine A cos B equal sine A plus B plus sine A minus B. 2 cos A sine B equal sine A plus B minus sine A minus B. Let's do that first. So if you could simply add equation 1 and 2, left hand side is sine A plus B plus sine A minus B, that's what we want. And the right hand side, the cos A sine B will be cancelled out because of plus minus. Therefore, what we left with is 2 sine A cos B. So 2 sine A cos B equals sine A plus B plus sine A minus B. That is this one, ask you to find. And the next one, subtract second one from first. So sine A plus B minus sine A minus B. When we subtract, the first part will cancel out. Sine A cos B will cancel out. And the negative become positive. So 2 times cos A sine B. From there, 2 cos A sine B equal sine A plus B minus sine A minus B. That's this one. So let's hence solve 2 sine 3 theta cos 2 theta equals sine 7 theta is the equation given that we need to solve that equation or find the value for theta. And the theta range is given is greater than 0, less than pi by 2. Let's do that. So this is what we've been given, the equation. So left hand side I'm taking it. So sine 3 theta cos 2 theta is right. So we're going to use 2 sine A cos B equation. This equation to this equation. If we could use that, 2 sine A cos B equals, so A and B. A is simply 3 theta. If you compare that, 3 theta, B is 2 theta. So if you could use that, sine A plus B, 3 plus 2 is 5 theta, plus sine A minus B, 3 minus 2 theta is theta. So that is this one. Then going back to the actual equation, the left hand side we have found sine 5 theta plus sine theta. So if I could write for that for left hand side, sine 5 theta plus sine theta equal, the right hand side is simply sine 7 theta. If I could rearrange it, take it to one side, sine 7 theta minus sine 5 theta minus sine theta equal 0. If you look at it, we have 7 theta and 5 theta. So try and work out the one we used in the first part, sine A plus B, sine A minus B business. So just 7 theta can be written as 6 plus 1. phi theta written as 6 minus 1. So that comes into a minus b, a plus b format. So sine theta, sine theta. So this one, we can simply use sine a plus b format is 2, so sine 6 theta plus theta, that is equal sine 6 theta cos theta plus cos 6 theta sine theta. And sine, the next one is sine 6 minus. So this is equal. And next one, sine 6 theta minus theta. So sine A minus B format. So sine 6 theta cos theta minus cos 6 theta sine theta. So this is say P, and this is Q. If we could, what we need is a minus in between, so P minus Q. So P minus Q. Simply, if we could minus it, what we have sine 6 theta cos 6 theta in sine theta cos theta will be cancelled out. That will be cancelled out. All we have cos 60 theta sine theta is another cos 60 theta sine theta. That is 2 cos 60 theta sine theta, and the sine theta is sine theta. If I take sine theta out as a common, 2 cos 6 theta minus 1 equals 0. So there are two values we can get. Sine theta equals 0. From that, theta equals 0. That is invalid because of theta is greater than 0. Therefore, that's invalid. The only value we have 2 cos 60 theta equal 1. 2 cos theta equal 1. From that, cos 60 theta equal half. Half, cost value half is pi by 3. It's positive or negative by 3. So 60 theta plus or minus pi by 3. But we can't get minus because the value in the range is greater than 0. Therefore, minus invalid. So only prime value we have 6 theta equal that. So 6 theta equal pi by 3. From that, theta equal 5 by 18. That's a prime value. Now we can use the common term for cos 60 theta equal 2n pi plus or minus pi by 3. N is an element of integer. So theta, just simply say divide by 6. Then n pi divided by 6 plus or minus pi over 18. 2n pi divided by 6 plus or minus pi over 18. N equals 0, we get this first value, which is pi over 18. N equals 1, 2 pi over 6 plus or minus pi over 18. When you work it out, one is 7 pi over 18, and the other one 5 pi over 18. So obviously, both are less than pi by 2, greater than 0. So those values okay as well. And n equals 2, theta equals 4 pi over 6 plus or minus pi over 18. Then you work it out, 13 pi over 18, 11 pi over 18, both are greater than pi by 2, therefore invalid values. So only 3 values we have for theta. Those are theta equal pi by 18, 5 pi by 18, 7 pi over 18. Those are the 3 values we asked us to find. Yes, that's done. Second part, part B. In a triangle ABC, the point D lies on AC such that BD equal DC and AD equal BC. Let angle BAC is alpha, angle ACB is beta. Using the sine rule for suitable triangles, show that 2 sine alpha cos beta equal sine alpha plus 2 beta. Let's do that first. So I've got a triangle ABC and draw it a few times to get the perfect triangle which fits to our input. So this is ABC. The angle BAC is given, is alpha, and angle BCA or BC, that is given beta. And then again, the side BD equal DC. BD this side is equal. So triangle BDC is isosceles triangle because those side, if it's one's beta, the other one should be beta too. And AD equal BC, AD equal BC. This call it this one. I want to construct this for a reason. I'll come to that in a minute. So E value, right? Take ABD, the top triangle, small triangle, ABD. We just have to, before we do this sign rule, let's do with this. This BDC is isosceles triangle. That's beta, beta, if 2 beta, and then external angle, this one, this ADB is 2 beta because of external angle equal sum of internal angles 2 beta. From that, one ABD triangle, that's this one is 180 minus alpha plus 2 beta. So this, we need to use it. Right, okay, sine rule. Rule here. So sine alpha is angle and opposite side BD. And sine another angle is 180. Sine 180 minus alpha plus 2 beta. Opposite side is AD. From that, sine alpha over BD and sine 180. Sine 180 minus say A, that is equal sine A. That is exactly what I did here. So sine 180 alpha plus beta is sine alpha plus beta divided by AD. And cross multiply AD over BD sine alpha equal sine alpha plus 2 beta. Just keep it that way. Let's call it as equation 1. Now I just did this construction for purpose, and then this is a perpendicular from D to that side BC that meets at E, and because of isosceles triangle that's perpendicular, it will split BC into half, so B equal AC. Anyway, right. Taking that triangle BDE, BDE triangle. This is a right angle triangle. From that, cos beta equal opposite side, adjacent side over hypotenuse. That is B adjacent side, the hypotenuse BD. So B over BD. From that, B equal cross multiplication BD cos. So BE equal BD cos beta. BD is half of BC. That is what I got it here, half of BC. So BD is half of BC. BC equal AD. Therefore, half of AD. B equal half of AD. So cos beta equal is cos beta equal half time AD over BD. From that, we can find out, say, cos beta equal half time AD over BD. Just simply substitute that B is half AD and BD is BD. So half time AD over BD. AD over BD equal to cos beta. From that, now I'm going to go back to that equation. Cos alpha cos beta. So right, with the equation they ask us to use it, of course. Here from that, just using the suitable triangle, show that sine alpha cos beta equals sine alpha beta. So right, okay. First of all, we have we found this AD. All right, okay. Sine, if you look at equation 1, this is just 1. We have sine alpha there, and then AD over BD, that is cos 2 beta, so 2 and then cos beta, that is equal sine alpha plus 2 beta. This is what we have been asked to prove. That's done. The second part, if alpha is to beta equal 3 is to 2, using the last results in A, part A, we'll come to that, above, show that alpha equal pi over 6. For part A, we have an equation given 2 sine 3 theta cos 2 theta equals sine 7 theta. That is what we've been asked to prove, I believe. Yeah, let's see. Right, okay, that's done. Right, this alpha or beta equal 3 over 2. Alpha is to beta equal 3 is to 2. The alpha or beta equal 3 over 2. From that, beta equal 3 over 2 alpha. Okay, the first term, if we could simply substitute that this beta equal 2 or 3 to this equation, what we have 2 sine alpha instead of beta is 2/3 beta alpha, so cos 2/3 alpha equal the right hand side sine alpha plus 2 beta, that is 2 times 3 over 2 is 4 alpha plus. If I could compare the first part equation which we have been given, 2 sine theta times cos 2 theta, 7 theta is given this equation. So we can compare this one to our equation, this equation. So it's sine alpha, here sine 3 theta. So 3 theta equal alpha, 3 theta equal alpha. So theta equal 1/3 alpha. Yeah, that is exactly right. 2 is 2, 3 theta is alpha. So theta is, we can write that alpha is, so alpha equal 3 times 1/3 alpha. Alpha equal the same thing. If I could, the next one is 2 times alpha is the 2/3 alpha. So 2 times 1/3 alpha is 2/3 alpha. So we have 2 cos 3 sine 3 theta cos 2 theta. We have 2 sine alpha cos 2/3 alpha. So 1/3 alpha is theta. Just simply here we have 7 theta, and if you work it out, this 3 plus 4 is 7 over 3. So 7 theta, 7 times 1/3 alpha is 7 alpha over 3. So theta equal pi by 18, we have found that value, of course, here, the first value, we have found theta equal pi by 18. If it's theta equal pi by 18, now what we said that is theta is 1/3 alpha. So in other words, 1/3 alpha equal pi by 18. Simply just we solve this equation and the same similar equation in terms of alpha. So we have find it. So from that, alpha equal pi by 6. So alpha is pi by 6. Is that what they asked for? Yes, alpha equal pi by 6. That's done. Second one, part C, solve 2 tan inverse x plus tan inverse x plus 1 equal pi by 2. Hence show that cos pi by 4 minus half time tan inverse pi 4 over 3 equal 3 over 10, 3 over root 10. Okay. All right, this is given. So 2 tan inverse x plus tan inverse. So just this angle term. So 2 angles at 2 times angle, another angle at pi by 2. Add together is equal pi by 2. So a tan inverse x, just took it as a. So that means x equal tan a. And tan inverse x plus t, I took it as a b. So x plus 1 is tan b. So simply, if you look at that tan inverse x, that is 2a plus b, that is pi by 2. That's the same. Substitute that value and find this. From that, 2a equal pi by 2 minus b. Tan 2a, of course, we can take tan both sides. Tan both sides. Tan both sides. So tan 2a equal tan times pi by 2 minus beta. That is b, sorry. Tan pi by 2 minus, say, x equal cotangent x. As simple as that. So tan 2a equal tan pi by 2 minus b. So tan 2a equal cot b. Tan 2a, we can make it in a single angles because so that's what we have, x and x. So 2 tan a divided by 1 minus tan squared a equal 1 over cot b is 1 over tan b. So simple, we have got all single values. Tan a is x. We just took it as tan a is x. or A is tan inverse x. So from that, if you substitute that, 2x over 1 minus x squared and 1 over x plus 1, because of tan B is x plus 1. So simply, if you cross multiply it, 2x times x plus 1 equal 1 minus x squared. If you bring that x squared to this side, well, before that, just remove the bracket. 2x squared plus 2x equal 1 minus x squared, and bring that x squared and 1 this side. So 2x squared plus x squared is 3x squared plus 2x minus 1. And this is a quadratic equation. We can simply factorize it. So factorize that, put a little cross, and 3x and minus 1 and 1. So these are the two factors. One is 3x minus 1, the other one x plus 1. But x plus 1, x equal minus 1. So I'll take that two values for x equal 1/3, x equal minus 1. Before that, x plus 1, we took it as tan B. That can't be equal 0 because it has a value or angle. So x equal minus 1 is not invalid value. So just we only stick with x equal 1, because if you do that, then the whole thing is, tan B is meaningless. So tan B it has a value. So x plus 1 cannot be tan 0 because we took x plus 1 is tan B. Right. So if I could, this is the equation is given. We ask us to prove that cos pi by 4 minus half times tan inverse 4 over 3 equal 3 over root 10. We have to prove. Okay, left hand side. Before that, we have given another equation, that the starting equation, this one. So I'm rewriting that equation and work out from that. So that equation is 2 tan inverse x, tan inverse x plus 1 equal pi by 2. And so if I could substitute the value, because x is 1/3, we proved it, we found it. So x equal 1/3, so 2 tan inverse 1/3 plus tan inverse 4 over 3 x plus 1 is 1/3 plus 1 is 4 over 3 pi by 2. And then if I divide both sides by 2, that is tan inverse 1/3 plus half tan inverse 4 over 3 equal pi by 4. Pi by 2 divided by 2, pi by 4. So simply bring that to one side. Because we need to prove the cost value. So just what is inside the cost is pi by 4. So let's see, pi by 4, I'll keep it one side, and I purposely took half tan inverse 4 over 3, which we needed. So I took it the other side. So I took that one side, pi by 4 minus half tan inverse 4 over 3. We just got it. And the other side is tan inverse 1/3. If I could take these, all our values, pi by 4 and tan inverse, all our angles. So I just know, I can take that as A, because this one is tan inverse x. We know tan x equal A. So I just put it A for this one, because we took it as initially A. So I just use the same notation, A. So this is an angle, A. So if I take both sides, cos pi by 4 over tan inverse 4 of 3, that is exactly what we want on the left hand side. The other side is cos A. We need to prove 3. Cos A is 3 over 10. The reason why, because tan A, we know that from that tan A is tan A equal tan 1/3. Tan A equal tan inverse 1/3. So that is, if I could take a small right angle triangle, call it this A. So tan is 1/3. Tan A is 1 over 3. And this is hypotenuse, Pythagoras, 1 squared, 3 squared is 10. Hypotenuse is root 10. So cos A, from that, cos A is 3 over adjacent over hypotenuse, so 3 over root 10. That's the value we need to prove. That is the final part of the question. Yes. Thank you. Please subscribe the channel and share this content with other students and friends. Thank you.